This lesson is on the orthocenter. We'll start with the altitude of a triangle. The altitude of a triangle is the line passing through the vertex and perpendicular to the opposite side. So let's draw one here. I'm not going to construct it. That would be the best way to do it, but I'm not going to take that time for the moment. So the altitude would be through the vertex and perpendicular to the opposite side. So that is an altitude. Draw yourself a random, generic, acute triangle there in your cipher and draw in all three altitudes. The altitude, again, is the line passing through the vertex and perpendicular to the opposite side. When you draw all three of them, it will look something like that. The concurrency which is right here in the middle. This is the orthocenter. And it is the concurrency of altitudes. So there we have concurrence of altitudes. Notice that this is an acute triangle and that the orthocenter is inside of the acute triangle. There in your cipher, draw yourself a small right triangle and draw in all three of the altitudes. When you do, you see you're going to have a difficulty. It's going to look kind of weird. It's going to be like this because you must draw from the vertex to the opposite side and be perpendicular. Well, that just happens to turn out here at the right angle. So, with a right triangle, the orthocenter is at the right angle. Then there, if you would, draw an obtuse triangle. You're going to do the same thing, but notice here you're going to have a difficulty because when you try to do a line perpendicular from this vertex, there's no side of the triangle there. To be able to do it, you're going to have to extend the side of the triangle. So what we have here is that the altitude goes through the vertex and is perpendicular to the opposite side of the triangle, but it doesn't actually touch the opposite side of the triangle. So go ahead and do this for all three of the angles of your obtuse triangle. When you get it done, it'll look something like this. The orthocenter will be outside of the obtuse triangle, and it will be, shall I say, behind the big angle. So it's outside and behind. In summary, we notice how the orthocenter relates to the different shapes of the triangles, the different types of triangles. Here in the acute triangle, the orthocenter is always inside the triangle. The right triangle, the orthocenter moves back to the right angle itself. In the obtuse triangle, it keeps on moving. It was inside, then at the right angle, and now that it's an obtuse, It's out here in the back, behind it. So we have the orthocenter inside for an acute, on the right angle for a right triangle, and behind, I'm saying, the big angle in the obtuse. You'll recall that in the circumcenter, if you'll look back a couple of triangles ago, we did small triangles with the acute, right, and obtuse. On the acute one, the circumcenter was also inside. On the right triangle, the circumcenter was on the hypotenuse and then moving the other direction. And then on the obtuse one, it was out in front of the big angle. So in the orthocenter, it moves the opposite direction than it does in the circumcenter. Let's draw this. By one way or another, folding may be the easiest. Make lines that go through, altitudes that go through the vertex and perpendicular to the opposite side. That's what I've done here. Through the vertex, I know that it's perpendicular to the opposite side because I folded 180 half in two, so that makes 90. Now, if you would, please draw these all the way down. We need to show where they're perpendicular. And label it altitude. Go ahead and do all three of them. It should look like this. Label that that's the orthocenter and it's the concurrency of altitudes. You'll keep this in your cipher. And here is the Orthocenter Theorem. The Orthocenter Theorem doesn't say a whole lot. It just basically says there is an orthocenter. When you draw the altitudes, they are concurrent. The Orthocenter Theorem, the altitudes of a triangle are concurrent. Here in this lesson. It's the one that says algebra, the other one that starts with distance and doesn't have a title. Hello. Wow. I want to look at the, I don't understand.
I don't understand anything right now. Did you ask Sarah?
Okay, everybody, sit down and read something or something and be all the way quiet, because I've got one more geometry lesson to video here. So you can just hear my geometry lessons, but just don't say anything, okay? They can't see, so I'm recording it. That's what I'm doing, and then I post it online. Okay? Yeah. It's not going to be but 5 minutes, but yes, you can. What happened? It let me pause it.